Welcome to Global Watch. Please subscribe and hit the bell icon for more breaking updates beneath the tranquil pines of Eastern California, where the air is crisp and the landscape seems untouched by time. A hidden force lies in wait. Here, a geological giant stirs. The Long Valley Caldera, one of the world's most closely watched supervolcanoes. This vast volcanic depression, born from a cataclysmic supereruption over 700,000 years ago, is not just a relic of the past. It's a living, dynamic system that continues to evolve. Recent research has revealed a complex and ever-changing world of magma chambers, volcanic gases, and subtle seismic tremors deep beneath its surface, painting a picture of ongoing activity. The caldera acts as a natural laboratory, offering scientists vital clues about the immense forces that shape our planet and threaten global stability, from earthquakes to climate shifts. Supervolcanoes like Long Valley have the power to alter global climate, disrupt societies, and impact life far beyond their immediate surroundings, making their study more crucial than ever. Today, scientists use cutting-edge technology, drones, satellite imaging, and real-time sensors, to decode the caldera's subtle signals, distinguishing normal volcanic activity from early warning signs of unrest. Each new discovery refines our ability to predict volcanic behavior, not just here in California, but at supervolcanoes around the world, improving our preparedness for the unexpected. The story of Long Valley is one of both danger and opportunity, a place where ancient powerful forces meet the ingenuity of modern science and where every breakthrough brings us closer to understanding Earth's most dramatic events. As we explore its secrets, we learn not just about the caldera itself, but about how to live safely and responsibly in the shadow of Earth's immense power, preparing communities for whatever the future may hold. The beauty of Long Valley hides immense energy, and for the first time, we are finally learning to listen and to understand what this ancient landscape is telling us. To truly understand Long Valley's present, we must first journey back in time to its explosive origins. The story of this caldera begins with a cataclysm, an eruption so immense, it forever altered the landscape of Eastern California. 760,000 years ago, a colossal volcanic event erupted with unimaginable force, reshaping the region in a matter of days. The eruption caused the ground to collapse as a massive magma chamber emptied, blasting over 600 cubic kilometers of ash and rock into the sky. The aftermath was nothing short of apocalyptic. Pyroclastic flows, superheated and fast-moving, scorched everything in their path, leaving devastation in their wake. Ash clouds blotted out the sun, darkening skies across the continent and altering the climate for years to come. The Bishop Tuff, a thick layer of volcanic rock, is a lasting reminder of this eruption. Its remnants can still be found as far away as Nebraska, over 1,000 miles from the source. The eruption left behind a vast, 10 by 20 mile depression, what we now call the Long Valley Caldera, a scar on the Earth's surface. But the story of Long Valley didn't end with that ancient disaster. The caldera has remained restless ever since, its volcanic heart still beating beneath the surface. Over millennia, magma has pushed up a central dome, and smaller eruptions have continued to shape the landscape, reminding us of the forces at work below. Even in recent geological history, the region has experienced swarms of earthquakes and episodes of ground uplift, clear signals that the Earth here is far from quiet. These are reminders that the magma chamber below remains active, its energy simmering just out of sight. Hot springs and fumaroles dot the caldera's landscape, venting steam and gases from deep within the Earth. These features are vivid evidence of ongoing geothermal activity, a testament to the caldera's persistent heat and power. Since the 1970s, periods of unrest, including powerful earthquakes and rapid ground movement, have kept scientists vigilant, monitoring every tremor and change. Long Valley's legacy is one of fire, transformation, and constant change, a landscape shaped by both destruction and renewal. Today, scientists use advanced instruments to track the caldera's every move, seeking to understand its present-day behavior and anticipate what might come next. Its history stands as a powerful warning, reminding us that beneath the calm surface, danger can still lurk. Beneath the tranquil landscape, the volcanic system remains alive, its story still unfolding beneath our feet. To truly listen to Long Valley, scientists turned to a revolutionary tool fiber optic cables. Caltech researchers transformed a 100-kilometer cable into thousands of seismic sensors using distributed acoustic sensing, or DAS. This technology detects even the faintest ground vibrations, capturing over 2,000 microquakes in just 18 months. Machine learning algorithms sifted through this data, mapping the caldera's subsurface in unprecedented detail. The result? A high-resolution, 3D image of faults, fractures, and fluid pathways deep below. This approach marks a paradigm shift, placing sensors every few meters, not miles, for continuous observation. Scientists can now track how seismic waves move through rock and fluid, revealing the volcano's internal workings. The success at Long Valley sets a new standard for monitoring hazardous volcanoes worldwide. With fiber optics and AI, we're seeing the Earth's secrets clearer than ever before. The most reassuring discovery? Long Valley's restlessness isn't a sign of imminent eruption. High-resolution data shows the deep magma reservoir is cooling and solidifying, not heating up. As magma crystallizes, it releases water, CO2, and gases, which migrate upward, causing ground swelling and microquakes. This process explains decades of seismic swarms and deformation, activity driven by cooling, not rising magma. The system is noisy and dynamic, but not on the verge of catastrophe. However, the release of pressurized fluids can still trigger hazards, hydrothermal explosions, steam-driven blasts, and moderate earthquakes. Understanding this cooling paradox shifts the focus from super-eruption fears to more likely, localized events. Scientists can now better define and prepare for these smaller, but still significant, risks. The caldera's activity is a reminder. Not all unrest means disaster, but it always demands respect. Knowledge is our best defense against the unknown. Scientists stress these findings call for vigilance, not alarm. It's crucial to understand that while the data may seem alarming at first glance, it is part of a natural process. Dr. Jongwon John of Caltech emphasizes that Long Valley is cooling, not building toward a super eruption. This cooling phase is a sign of the volcano's gradual decline. The volcano is in its twilight years, active, but not explosively dangerous. Its activity is more akin to a gentle simmer than a violent boil. Yet the cooling process itself can generate earthquakes and small eruptions, so complacency isn't an option. These minor events are reminders of the volcano's presence. Local hazards, steam explosions, gas releases, moderate quakes, remain real for nearby communities. These hazards necessitate ongoing vigilance and preparedness. The U.S. Geological Survey and California Volcano Observatory have monitored Long Valley for decades, and the new data sharpens their forecasts. Their continuous efforts are crucial for public safety. The consensus, while the immediate threat is low, our ability to interpret warning signs has never been better. This improved understanding helps mitigate potential risks. Data-driven knowledge replaces fear, empowering scientists to distinguish normal activity from true escalation. This scientific approach is key to effective risk management. The call is for continued investment, public awareness, and preparedness. These elements are essential for community resilience. Living near Long Valley means coexisting with risk, but understanding it is the first step to safety. Knowledge empowers residents to take proactive measures. Science turns anxiety into action. By staying informed and prepared, communities can face the future with confidence. The fiber optic breakthrough at Long Valley is just the beginning. Scientists plan to install a new 200-kilometer cable encircling the caldera for even deeper real-time monitoring. This network will integrate with traditional seismometers, GPS, and gas sensors, creating a unified picture of volcanic health. Machine learning will be essential, processing vast data streams and flagging anomalies before they become threats. AI systems will learn the caldera's normal rhythms, providing early warnings of unusual activity. This fusion of hardware and software is the future of volcano monitoring, proactive, not reactive. The model pioneered at Long Valley can be adapted to volcanoes worldwide. By listening closely, we gain precious time to prepare. Long Valley's geology shapes daily life for local communities and millions of visitors. Mammoth Lakes thrives on tourism, drawn by the region's beauty and geothermal wonders. The reassurance that a super eruption is unlikely helps protect the area's reputation and economy. Still, the risk of smaller hazards means public education and preparedness are essential. The caldera's geothermal energy powers thousands of homes, making it a key renewable resource. New research could improve energy production but also highlights the need for careful management. Life here is a balance, enjoying nature's gifts while respecting its risks. Scientific insight empowers smarter decisions for a resilient future. Long Valley is just one of California's many active volcanic centers. From Mount Shasta in the north to the Salton Buttes in the south, the state is shaped by tectonic forces. Each volcano has its own history and hazards: Shasta's eruptions, Medicine Lake's vast shield, Coso's geothermal power, and the young domes of the Salton Buttes. These systems threaten with lava, mud flows, and earthquakes, each requiring tailored monitoring. Long Valley stands out for its massive ancient eruption and ongoing ground deformation. Its current unrest, driven by cooling magma, is different from the fresh magma threats at other volcanoes. Understanding these differences helps scientists refine hazard assessments across California. The state's volcanic diversity demands constant vigilance and innovation. The revelations from Long Valley mark a turning point in how we coexist with Earth's power. Science has replaced fear with understanding, showing that the caldera's restlessness is a sign of cooling, not catastrophe. Fiber optics and machine learning have become our sentinels, watching for subtle changes and providing early warnings. Continuous monitoring is our best defense, guiding emergency planning and public safety. The story of Long Valley is a testament to global scientific collaboration and innovation. What we learn here protects communities worldwide, from California to Indonesia. Respect, readiness, and research are our tools for living with restless giants. The caldera may be cooling, but our vigilance must remain as active as ever.